So welcome students. So in this question, you're given that you have numbers starting with 1, 2, 3, 4, 5, 6, 7 and 8. You have these 8 numbers. You're selecting 2 digits out of this without replacement. That is, if you take 3, next time you cannot take 3. So that is, you're selecting 2 different digits effectively. And what is the probability that the minimum of these 2 digits is less than 5? What is the probability that the minimum of these 2 digits is less than 5? So you have 2 numbers. You have 2 numbers which have been taken out, and the minimum of these 2 has to be less than 5. So what is the meaning of it? So how do you find the probability? So to find the probability of this event, so let us first determine the denominator. What are the number of ways in which you can select 2 numbers out of these 8 numbers? That's nothing but 8C2. So the denominator will be 8C2. So let us fix that. So what should come in the numerator? So what are the favorable outcomes? So if the minimum of these 2 have to be less than 5, there are 2 options. Either both of them can be less than 5. If both of them are less than 5, the minimum will be less than 5. There is no doubt about it. The second case is, that is, both less than 5. And the second case is, one of these 2 is less than 5. Exactly one of these 2 is less than 5. Exactly one of these 2 is less than 5. That is, one is less than 5 and the other is 5 or more. So exactly one less than 5. Either both of them can be less than 5 or exactly one can be less than 5. If both are greater than 5, then the minimum will not be less than 5. You have these 2 options which satisfy this event, E, what is asked. So let us try to find these 2 probabilities and let us add them, because there is no intersection between them. Because if both of them are less than 5, it won't come into this case. If exactly one is less than 5, it won't come into this case. So what is the probability that both are less than 5? So the denominator is 8C2, there is no doubt about it. So the numerator, both of them have to be less than 5. That means both of them should come from 1, 2, 3, 4. That means you have 4C2 guys. Plus, exactly 1 has to be less than 5. So the denominator is 8C2 even now. So now that means 1 has to be less than 5 and the other has to be greater than 5. So one has to come from 1, 2, 3, 4. The other has to come from 5, 6, 7, 8. That is 4C1 into, so one, I select one of them from this set, and second is 4C1. So I have selected one from this set. So I have selected one from this and one from this. That is 4C1 into 4C1. So the total is, so 8C2, 8 into 7 by 2. 8 into 7, 56 by 2 is 28 in the denominator. So you have 4C2 is 6 plus 4C1 into 4C1, 4 into 4 is 16. That is equal to 22 out of 28. That is equal to 11 by 14 is the answer. So this is one method to solve this question. So you can also solve this in another way. That is, we can find the complementary condition. So here, the minimum of these 2 digits have to be less than 5. So what is the complementary condition to it? If both the digits are 5 or more, that means this condition is not valid. When will this condition be not valid? So if both the digits are 5 or more, then this condition is not valid. So what is probability of E bar? That is the complement of this event. The complement of this event says that none of the 2 digits should be less than 5. That means both the digits should be 5 or more. That is, both the digits should come from this set. That is 4C2 by 8C2. That is 6 by 28. That is equal to 3 by 14. So probability of E complement is 3 by 14. So what is the probability of E 1 minus 3 by 14? That is equal to 11 by 14 again. So you can directly do from this method or this method. So whatever you do, you have to be consistent with what you're doing. Thank you.